All right, we're working on I forgot what the name of it is already. It's been such a long time. It's been a while. It's a little Clinton, 49 Clinton. And I'm down here at Mike's.
How you
There
doing?
he is. Because I ran into a dilemma, and he's the only one that could figure it out for me. And tell him what's going on with this thing, Mike.
Well, the bore has been oversized at some point, but it's worn since that time. So it's worn past the oversize. So we got the dial bore gauge out, and we just drew our little picture here of the cylinder so we can visualize the wear that's in here. So
Before you get into that,
Okay.
I'm gonna tell him how I figured out something was wrong. Something went awry, because James Green sent me all these parts for Clinton, and originally this was 5 thousandths over.
well, it's a 2-inch bore that
Right.
was bored 5 thousandths oversized, right?
And so right away you need,
Well, if you want to, you need 5 thousandths over piston
Right.
and rings. If you wanted to put a fresh piston and rings in it.
and James Green sent me I think 2 sets of rings. See if you can find them in there, Mike. And I was checking the ring gap on them. And the ring gap on my originals, it was a big one. I mean, I forgot what it was, but it was like 4 or 5 times larger than it should be. And then,
Are they in with the piston here? Oh no, they're right here, aren't they?
right.
Oh, okay.
Look at the packaging on these, Mike. That's incredible, isn't it?
Yeah. Ring set. Oh, look at that.
Look how they set them up. The box, just that display is worth hanging on a wall. And they tell you how to put them in and everything.
So you have one set here. It's standard, right?
Right.
Okay.
And the same setup. But anyway, I took the original ones, and the original ones, we'll do that after Mike does all this, because he's going to put a bore gauge in here and see if how far out the cylinder is. And the way I knew something was wrong, because I checked the gap on the rings on all 3 sets, the originals and the 2 sets that James sent me, and they were just way too far out. So I said, let me see what the problem is with the.
Yeah, then you got a piston here.
Yeah.
That's probably a 5 thousandths over piston.
Right.
Because it feels okay in the top of the bore here, but once you drop it down, you can feel all the slop that it has.
Right.
But okay, well.
So that's how I come to the conclusion that the rings might not work. I might just have to use the originals. So let's get back to this, Mike. Your bore gauge.
Okay.
First show them the bore gauge, what it does.
Well,
Pretty interesting.
so you have to kind of calibrate this to every engine you're working on. So you take the standard size of the bore, which originally was 2 inches, but since it was bored oversized, we have to set it. No, wait a minute. No, I set it to 5 thousandths over, didn't I?
Right.
Oh, okay. We should cut the video now, buddy.
Okay. All right. Yeah, we thought we had a problem here because I mentioned something.
You
And
did.
then, I don't know when it's usually forgetting stuff, but Mike forgot this time.
I did. So when I let's start back. It's a 2-inch
Right.
bore from the factory. Some point in the past, it was bored 5 thousandths oversized. So what I did was I calibrated the bore gauge to 2 inches and 5 thousandths. So I just used a caliper here. So when you put the gauge to 2 inches and 5 thousandths, the needle is going to read 0.
Right.
So when I measured this bore now, whatever we read over 0, so in this case 0 would be 2 inches and 5 thousandths, but it's not here. At this point in the bore, which is the top of the stroke, we are 2 inches 5, 6, 7, 8, 9 thousandths oversized, over standard. So you could even call that 9.5, but we call it 2.009. Now that's not in the thrust direction. The thrust direction is this side here, and that came to 2 and 10 thousandths. Because remember, whatever this is, you have to add 5 thousandths to it. What is that, 6 thousandths or so? I'm not looking at the gauge.
Yeah.
So it's actually more. It's 11 thousandths. That's quite a bit. Now we did this 3 times throughout the length of the bore. We took one at the top of the stroke, one measurement at the top, one at the center and one at the bottom of the stroke. Not at the bottom of the cylinder, but at the bottom of the stroke of the piston. So just picture this cylinder here as the bore, the carburetor side over here, and then the flywheel side is what's looking at you here. So you can see I took a measurement here, parallel to the crankshaft, and one perpendicular to the crankshaft. The perpendicular measurements are typically going to be larger than the parallel measurements because, where's that little piston at? Oh, it's over there. This face here, depending on, right, these two faces, depending on which direction the crankshaft spins, these are going to absorb most of the side thrust of the piston while the thing is running. So you have to kind of visualize it like this. You got a piston here on a connecting rod. When the engine fires, the connecting rod is going to get pushed down to follow the crank. Well, because of that angle of the connecting rod, the piston is going to get forced on this wall with a lot of force. So most of the wear is going to occur on these edges of the piston and these edges of the bore. So this tells us a couple things. One, looking at these measurements, the bore is not a cylinder anymore. It's a cone. It's tapered. It's smaller down at the bottom than it is up at the top. Not only that, it's not round. It's oval shaped because it's wider in one direction than in the other. So it's pretty worn out.
It is.
I mean, all that yapping I just did is to say that looking at it now, it's worn between 5 and 6 thousandths over the 5 thousandths oversize that it already had. So in order to make this bore correct, we would have to take it to 20 thousandths over factory.
Right.
So we'd have to go to 2 inches and 20 thousandths. So if we did that, it would clean up all of these oval measurements, all of this taper in the bore is what you call it. So really we would need a set of 20 thousandths oversized rings and a 20 thousandths oversized piston to make this engine correct.
Right.
That doesn't even address any connecting rod wear or anything like that.
Right.
So, or any main bearing wear. That's just the bore itself.
So for what it is, you know, it's a show engine, and it's never going to be back in a service.
It'll run just fine.
Right.
I mean, remember that Model A Briggs that I did a couple months ago? That thing was worn worse than this, and it still made almost its rated horsepower. You know, it did. It's going to run.
Okay, the average person isn't going to do this because they're not going to have this gauge or the intelligence, including myself. But why don't we show them how to check the ring gap?
Oh, okay. Let me grab the rings.
Matter of fact, we'll do it on all three of them. Or maybe not, maybe just one, because this is a long video
Well,
already.
let's check the factory ring gap first.
All right. Mike is going to show you how to check ring gap on these, and all small engines are basically the same, and the specs are very similar. We don't have a Clinton book, but we do have a small engine book here, and here's the end gap, actually the reject size, and on cast iron it would be 30 thousandths on the compression rings, and then I was reading while I wasn't looking. Let me see if I can show you. Right here on the cast bores, it's 30 thousandths, and on the oil ring, it's 35 thousandths. So keep that in mind, and show them how it's done, Mike.
Well, okay, so we have...
You know, I did check the Clinton, and I forgot what it was,
Clinton book,
but I did see it on the internet somewhere.
Okay, well, we have the original ring that came with the engine. This is the top compression ring. So you just slip it in the bore you want to put it in the orientation that it would be when it's on the piston. So you just kind of slip it in there, rotate it over, and then you can use the crown of the piston to push it down like about an inch or so down into the bore. About an inch. The piston allows you to keep it, the ring relatively perpendicular to the bore.
Right, level or square.
Yeah, square. So we actually did measure this already. We'll do it again. So 30 thousandths would be the reject size. That's what we're going with. I actually had to use 2 feeler gauges, a 24 and a 25 thousandths feeler gauge.
I had to too.
To slip in that gap because it's so large. Can you see down that bore what I'm doing? So I'm just taking the feeler gauge and I'm measuring that gap right there just so I get a snug fit with the gauge. The gauge slips in there, but it can wiggle around a little bit. See that? So it's probably really about 50 thousandths gap rather than 49 thousandths. So that's 20 thousandths past the reject size.
Right. There should be a gap you know, but only enough for expansion.
Yeah, exactly. Only enough for expansion. I forget if it's 3/1000 per inch of bore size is the minimum, 3 or 5/1000 per inch of bore. So on a brand spanking new ring, I'd probably want 10/1000 or so worth of end gap. So we are 5 times that right now.
Right.
So that's
Crazy.
That's the ring that came with it. Now we have a set of rings that we believe are for a 5/1000 oversized bore. So we'll put those in, do the same thing, push them down with the piston about an inch or so. Okay, and that gap is tighter, which we would expect it to be. That gap comes in at, I have a 20 and a 22 here. There we go. So we got 20 and a 22, and it's a bit tighter. So I'm going to call that 42 thou gap, which is still 12/1000 past the reject size. But remember that this bore is worn, 5 to 6/1000 past 5/1000 oversize. So, we'll probably end up using these new rings because they're better. But that's not because the end gap is better. But that's not the only reason. One other thing I wanted to show you, which it's difficult to see on this ring. You want to get a close up here?
Let me see that, Mike. Yeah.
Can you see what
Well, show them on the paper what it looks like, so they know what they're looking at.
So here's a cross-sectional image of a new ring where is it at? This ring right here. In fact, so it's basically a square with a little bevel on the top corner here that faces the inside top of the ring groove. That's a new ring. The old rings that we pulled out look like this. These two surfaces here have worn down, smaller than the factory, and we have like a knife edge, you could call it, on the face of the ring itself. So this face here is the outside face of the ring. You got the old one there?
I don't know how well we'll be able to see it, but
yeah, we'll put it on the piston, and you'll be able to visualize how much wear there really is.
I don't know how well you guys can see that. Let me see if it's up on the white. We're dealing with different exposures here, but you see how sharp both of them edges are? Mike's never seen anything, nor have I.
No, not like that. That's significant. So let me just show you. Let's put this on the piston real quick.
Okay. Before you do that, Mike, let me show you the other piston. We were going to put a new piston in there. We got a brand new piston, but they have different oil rings. Put that side by side, Mike.
Oh, yeah, you see that?
The new oil ring is so much different, so we're just going to go with the old piston.
Yeah.
And new rings.
So here's the old ring. Let's see, is that correct? Yep. I'm just going to snap that on the top of the piston here. Okay. I'll pop it in the bore. Put the piston upside down. It really doesn't matter for this demonstration here. Okay. Now listen to this.
Look, you can actually see how much play there is in that
Right.
ring.
So the ring is not moving. I'm moving the piston on the ring, and you see all that backlash, that slop. That's
Show them there right now.
That's the clearance that the ring has in the groove. It can shift up and down that much.
Right.
That's and the thing is, the piston itself doesn't appear worn. It appears that the ring is the wear is in the ring. So let's try it with the new ring here. Real quick.
Actually, on bigger engines, Mike, they actually have shims if you want to fix that.
They do. They have shims, ring spacers they're called. Or on bigger engines you would cut the grooves
right.
oversize. So there's a new piston ring, and you can see that I can hardly move that ring up and down. And if we put it in the bore,
You don't hear nothing.
yeah, only the slightest bit of clearance there, of backlash. So it's not so much the end gap that we're improving, it's that slop
right.
there. So that's why we're going to go with the new rings on it.
It's not gonna be a perfect engine. It's just gonna be more better.
More better is a good word.
Okay.
Yes.
Okay.
All right, let's put this thing together.
And you know what? Mention something about the valves. We're gonna go with the old valves. James gave me a set of new valves, but we're just gonna go with these old ones for now.
Well, you cut the seats. You
We
cleaned
did.
the seats up a little bit.
And they should be good enough. So let's put this thing together and see how it runs. All right, Mike got the new rings in there, and he's got everything all lubed up.
Yep. Put a little bit of oil on the cylinder bore here. Got your arrow there.
I did.
Orientation.
You know, on a Clinton, I didn't see any marks. You know, like on a Briggs, you have the X, Mike.
Oh
tells
yeah,
you.
you have that X underneath, don't you?
Yeah.
X marks the spot, huh?
I don't know how much it would make a difference on something wore out as much as this is anyway.
Yeah, that's true. We're just fooling ourselves, aren't we?
I'm going to come over here and try and stay out of your way.
Thank you. Yeah, we're just putting these in. See if we can snap these in by hand. Rather than going to get the ring compressor. There we go. 2.
There isn't any bevel there like on the...
Well, some engines have it, some don't.
I know Maytags do.
Yeah. Well, you don't load the piston from the top on a Maytag. You load it from the bottom, don't you?
Huh. You
You
do.
don't have a head. Okay. That was easy enough.
Alright, looks like Mike's just about done inside. He's got his... turn it back the other way, Mike. Look at the shark fin on that. Look at that. That's completely different than a Briggs.
Yeah.
Pretty cool. So, Mike's got his tabs bent over on his connecting rod, and he's oiling everything up. So,
Yeah, we're gonna button the bottom end up here, right?
yep.
Put the base on. You got a new gasket.
New
for that,
gasket.
right?
There should be one in there from Jim. The other side, Mike. Oh, no, you're right, you're right. I closed that up.
Yeah.
There's a couple different ones in there.
Oh yeah, got an assortment. Couple still on the bottom there.
That's the
That
one right
looks like
there.
it right there,
Yeah,
right?
Yep.
So it's on there like so.
Fussily.
Okay.
All right.
Let's put that
Now
base
let's
on.
find the base. All right. We got the breather on for the valves. And
Yeah, a little breather in there. Looks just like a Briggs, almost just like a Briggs breather.
Mike's just gonna put the cover on. All right. Putting the carburetor on now and putting the heat shields on there. I made new gaskets. I remember, if you guys, it's been a while, but when I took the old ones off, here are the old ones, and almost look like restrictors, but they actually shrunk. So I made new ones with a big hole there. So this thing ought to breathe a lot better, Mike.
High power.
Breathe in. It probably won't suck any air because Mike is putting,
Well,
he's shellacking them together.
yeah, with all these shims and gaskets, I mean, the last thing we want is an air leak at this point.
Exactly.
You know?
All right.
We shouldn't have that now.
All right. Mike's putting the carburetor on. He's got the heat shields on, and he just hooked the linkage up. And
Yeah.
he's just doing this. This is like a puzzle to him because he didn't even see this thing come apart.
Yeah, I haven't worked on a Clinton in I don't know how many years.
A lot of times when I put these together myself, I usually have to go back and see how I took them apart. But I think Mike likes doing it this way because it's
I do. If you use a manual for the stuff like this, I think it's kind of cheating because you don't learn anything.
right, right.
You know.
And
It's
then this is like a
reading book.
puzzle. This is a challenge.
Right. Yeah.
And it always works. And if it don't work, then you figure it out.
Right. Exactly. That's the fun of it.
It is.
Reading the manual is not all that fun, is it?
Nah, it's like instructions. Who needs them?
Yeah.
All right, let's check up, see how Mike's doing here. He got the cover on here, got the key in, got the carburetor on, and not many screws left.
No. The parts pile's getting smaller.
Yep, it's always a good sign.
Got little Phillips head screws here, huh? Pretty rusty.
Hmm. All right, got the flywheel on. You're putting the starter cup on.
Just put that on loose. Let's see if we make sure we have spark before we crank anything down.
Oh, look
yeah,
at that!
that's
Wow,
good spark.
that is, man. That's a lightning bolt.
That is. All right.
All right, let's see where we're at here, Mike. Get the shroud on. You got to put the sediment bowl on.
Yeah.
But you have the head on, side shroud, and what else? That's about it.
Yeah.
All right, keep going, buddy.
All right.
All right, we're almost there. Got the spark plug in, new wire, not a new wire, but a new end on there. Let me turn it around. Got the gas hooked up, gas tank. What's going on over here? You're gonna, you gotta put the air filter on, and I think that's it. Put oil in it and
Yep.
gasoline, and hope for the best.
That's right. Give it a start.
All right, we'll see you. We'll see you. We're gonna start in here, or outside, Mike.
We'll give it a first test in here.
Okay. All right. Mike just got done mounting on this piece of wood, so I think we're ready to bring it outside and clamp it to something, huh?
Yeah, I think we'll clamp it on that that engine cart that's out there, nice and heavy.
All right.
It should work fine.
I'd give you a hand with that, but I got the camera in my hand.
Oh, I understand.
Okay.
You always have
Oh, you already brought the clamps out? You know what?
clamps are out.
I'll bring this string out.
I gotta put some gas in it.
All right.
I don't think I put enough in there.
All right.
That'll work.
We'll get some gas and then we'll try and start it.
I think so.
All right. Mike's gonna put some fuel in it. Don't put too much in there, Mike.
Yeah.
Just enough to get it running. Yeah, this Clinton is 1.5 horse, and if you look at Mike's other engine here, it's 4 horse.
Right.
The size of that monster.
The thing
That's
is,
actually a flame engine, right, Mike?
so this is a 1.5 horsepower at 3,200 RPM. This is 4 horsepower at 450 RPM. That gives you an idea of the amount of torque that this thing produces rather than that. But, you know, different applications. Yeah.
Yeah. Well, we're looking at it, Mike. This, what do you call
It's
this?
a hot tube. Yeah,
A hot tube,
hot
right?
tube engine. Yeah.
This doesn't run on a spark plug. Just runs on a flame. Keeps it going.
Yeah, there's literally a pipe inside of this chimney, they call it, and it is heated by a gas burner, and when it's running, the compression pressure forces the air-fuel mixture up into that pipe, and it being red hot, it ignites the fuel mixture, and it initiates a power stroke.
You never did a video on this one, did you?
I did 2 videos on it,
Did you?
actually.
But not while it was on the cart?
No, I just put it on the cart yesterday.
Brand new
I want to
cart.
bring it to a show, and this is
All
the
right.
cart it's going to be on.
Yeah, me and Mike will be going to a show in 3 weeks, and he's going to bring this, so you'll see this thing running.
Yeah.
It's pretty cool.
This.
But let's get back to this little Clinton. Let's get this done. We've waited long enough for this.
Okay.
I'm banking on you. Pull through a few times and then start it.
So the choke is spring
There we
loaded
go.
here, huh?
Yeah. There we go, Mike.
Almost.
Oh, almost.
Might need to give it a little throttle.
All right.
Got pretty good compression.
That little bit of a noise you guys heard was the wood clapping against the back here. Wow.
Well, what do you know?
Yeah. You know, for an old worn out engine, I don't see any smoke.
Yeah, only when I goosed the throttle did it puff a little bit.
Yeah. That surprises me as worn out as that cylinder was.
I can't believe how nice it's idling.
Huh.
Look at that, you can almost count the revolutions. Quiet.
Yeah.
I'm falling in love with it.
Yeah. a nice little engine.
Yeah. It's pretty compact. You know, it's not, you don't, it's nice having the gas tank up front instead of having something over here and something over there.
Right.
It takes up less space. It seems to run really nice.
It does. All right, shut it down, buddy. All right, well, there you go, guys. I appreciate you hanging in as long as you did, but that's just how things work with me and Mike. You know, during the winter, we play with stuff like this, and then as soon as the spring hits, we move on to something else, and usually do the show circuit, so we don't have much time for this, but we had to get this done. And I want to thank James Green for helping us out and sending us all the parts and stuff like that. And
giving us a fresh set of rings in this old thing.
And Mike, what's Krusty Mike from Indiana?
Yep.
They gave us this engine, so all right, we're going to wrap this one up. What do you say, Mike? Enough?
Enough of this.
All right. See you guys on the next one.